Good morning, children. In the previous session, we have learned Thales theorem or basic proportionality theorem, and we have done the sums based on the Thales theorem. Now, we can continue with the previous session. Today, we have to learn about the criteria for similarity of the triangles. Now, many criteria is there. First one, AAA criteria. Yes criterion we have, and yes criterion, and so on. Many criteria we have here. See, what is that? In any similar triangle means always two triangles. We need to compare. You know that two triangles are similar if the following two conditions holds good. If they are equiangular, that means angles of the first triangle are correspondingly equal to the angles of the other triangle, and corresponding sides of those two triangles are said to be in the proportion. These two conditions must hold good. Is it required to compare every time these two conditions? No. One is enough to say that other one also holds good. What is that? Short way. If two triangles are equiangular, then corresponding sides are in proportion. Conversely, if the corresponding sides are in proportion, they are equiangular. So, the given those two triangles are said to be similar if any one of these two conditions holds good. Now, there are many criteria we have. AAA. That means if three angles are equal in both the triangles, they are equiangular. Naturally, corresponding is a proportion, then they are said to be similar. Yes. If three sides of the first triangle are correspondingly proportional to the three sides of the second triangle, then they are said to be similar. Yes. If two sides and include angles of those two triangles, if one angle and two sides are said to be in the proportion, then they are similar. By using this criterion, we have to solve some of the sums in the exercise. Let us follow now. Yes. Look at this now. First up, they have given that whether these two triangles are similar or not. ABC is a triangle. PQR is also a triangle. They have given the angles. Angle A is 60 degrees. Angle B is 80 degrees. Angle C is 40 degrees. And angle P is 60 degrees here. This is 80 degrees. And this is 40 degrees here now. Look at this now. Angle A equals to angle P. Angle B equals to angle Q. Angle C equals to angle R. They are equiangular. Therefore, when they are equiangular, you need not compare all the three angles. Any two angles enough to say. So by AA criterion, these two triangles are said to be similar. For objective question, they may ask you whether they are similar or not. Angles, they will compare angles now. And one more example they have given. Look at this now. ABC is a triangle. In the same way, PQR is also a triangle. Here they have given the sides. 2, 3, 2.5 units, 6, 5, 4, 10. Anyway, you can take, look at this now. AB by QR is equal to 2 by 4 is 1 by 2. Similarly, BC by PR is equals to 2.5 by 5 is 1 by 2. AC by PQ is equals to 3 by 6 is 1 by 2. Therefore, corresponding sides are said to be in the proportion. If three sides of the first triangle are in proportion to three sides of the second triangle, then they are similar. In the first example, AA criterion we have used. Here, yes criterion we have used to say that they are similar here now. Next. Now, one more example, let me see whether these two triangles are similar or not now. ABC is a triangle. Angle A is 80 degrees, 2.5 units. units. On the triangle DEF, they have given here DEF. Yes, 5 units, 6 units, 8 units. No doubt. How do you compare here now? See, you know that yes, yes criterion. Is it useful to say they are similar? 2.5 by 5 is 1 by 2. BC by EF 3 by 6 is 1 by 2. These two corresponding sides of two pairs of corresponding sides are proportional, no doubt. But angle A 80 degrees, angle F 80 degrees, maybe they are equal, but included angle, if two sides are an included angle, if two sides of the corresponding sides are in proportion, if the included angles are equal, then they are similar. Here, AB and BC they have given means they have given angle B not given. Angle A is not included angle of these two sides. Therefore, these two triangles are not similar. This is the way to work out the sums here now. Next. Now, diagonals AC and PD of a trapezium ABCD with AB is parallel to DC intersect each other at the point to go. Using a similarity criterion of two triangles, show that OA by OC equals to OB by OD. Now, they are given very clearly ABCD is a trapezium. Always in any quadrilateral, if one pair of the opposites are parallel, it is a trapezium. In this trapezium, diagonals AC and BD intersect with each other at O. Using a similarity criterion, which criterion we have to use? Angles they have not given, sides they have not given. What to do? How do you compare these? What have to prove? OA by OC is equals to OB by OD. Now look at this now. In the trapezium ABCD, you know that AB is parallel to CD. That means AB is parallel to CD. Yes. In the trapezium ABCD, AB is parallel to CD and the diagonals are intersecting with each other at O. Now let us compare these two triangles. In the triangles AOB and these two triangles are compared. You know that angle OAB is equal to angle OCD. Why? When these are parallel, AC is a transversal, angle OAB equals to angle OCD. These two are a pair of interior alternate angles are equal. So, in the triangles AOB and COD, look at this now. Angle OAB is equals to angle OCD. Reason is that interior alternate angles are equal. In the same way, angle ABO is equals to angle CDO. Again, BD is a transversal. These two are a pair of interior alternate angles. So, angle ABO is equals to angle CDO. Is it required to compare over angle? Not required. By AA criterion, if any two pairs of angles are equal, naturally third pair of angles are equal. So, by AA criterion, yes, triangle AOB is similar to triangle COD. When two triangles are similar, then their corresponding sides are certain proportion. We have discussed now. Two triangles are similar. If both the condition holds good, they are equiangular, corresponding sides are certain proportion. Therefore, here look at this now. Yes, OA by OC is equals to OB by OD. Look at this now. OA by OC equals to OB by OD. Similarly, you can say that AB by CD, but we want to take only these two. Therefore, OA by OC is equals to OB by OD. So, to do this, we have used AA criterion. We have used here now to do the sums. Let us take some of the sums in this way. Question number 5. S and T are points on sides PR and QR of triangle PQR such that angle P equals to angle RTS. Let us draw one figure. So PQR is a triangle. S and T are the points on PR. S is the point on PR. T is the point on QR such that angle P equals to angle RTS. How do you get? Angle RTS. Let us join TS. They are given that angle P is equals to angle RTS. Show that triangle RPQ is equals to triangle RTS. Very simple. Yes. You know very well that? In the triangle PQR, S is the point. S and T are the points on the sides PR and Q are such that angle P equals to angle RTS. They only have given for us. Let us compare these two triangles. In the triangles, yes, in the triangles PQR and this triangle angle P is equals to angle T. See, corresponding words are written properly. Angle T. Angle R is equals to angle R. Yes. TSR, because look at when we are writing like this, angle P is equals to angle T, angle Q equals to angle S, angle R is equals to angle R. How do you compare? Angle QPR is equals to angle SPR. Reason, data, they have given that angle P equals to angle RTS, they only are given. And you know that angle PRQ. Observe very carefully, angle PRQ is equals to angle TRS because angle R is common for both the triangles. So, by AA criterion, you need not say AA like this. Any two pairs of angles are equal. Therefore, triangle PQR is similar to triangle TSR. That's all. Any one of these criterion can use to say that they are said to be similar here. Now look at this top, this is the way you have to go about that. PQR or RTS, anyway, all three are equal now. Next. Seventh sum they have given here. In the figure, altitudes AD and CE of a triangle ABC intersect each other at P. Show that there are four parts in this. Triangle AEP is similar to triangle CDP. Triangle ABD is similar to triangle CBE. Triangle AEP is similar to triangle ADB. Triangle PDC is similar to triangle BEC. Let us draw the figure, then you get the idea now. So, right. Now, what do you have to prove? First part here, look at this now. We have to prove that triangle AEP is similar to triangle CDF. Which are the pairs of the triangles to be proved as similar? Highlight that now. See, in the figure, in the triangle AEP and CDP. How do you compare? You know that already angle AEP is equals to angle CDP. Why? 90 degrees. They are given now. Angle AEP is equals to angle CDP is equals to 90 degrees. In the data only they have given for us. And one more angle we can compare. Look at this now. Angle APE is equals to angle CPD because they are a pair of vertically opposite angles. When two line segments are intersecting, they are a pair of vertically opposite angles. Therefore, we say that angle APE equals to angle CPD. Look at this now. So, reason they are a pair of vertically opposite angles. That is very important here, the basics. Again, you need not compare one more angle. By AA criterion, triangle AEP is similar to triangle CDP. This is the way you have to go for the next second part. What we have to prove now? Look at this now in the same way now. Triangle ABD is similar to triangle CBD. Look at, observe from the figure. Then you get an idea now. See, we have to prove that these two triangles are similar. Means these two triangles only have to choose. There is no other go here. Look at this now way. Triangle ABD is similar to triangle CBD. See, ABD triangle C. How do you compare? Which are the angles do you know? See first. In the triangle ABD, angle D is 90 degrees. Correct? In the triangle CBE, angle E is 90 degrees. Compare these two angles first now. We know very well. Angle ADB is equals to angle CEB is equals to 90 degrees. Reason from the data. Now, angle B is common in both the triangles, you know very well. So, angle ABD is equals to angle CBE. The reason is that common angle of both the triangles ABD and CBD. So, same criterion. Why? AA criterion. Yes, triangle ABD is similar to triangle CBD. That's all. Observe carefully which are the two triangles they ask. Try to compare the angles. What angle you know? Common angle will be there. So, by AA criterion, they are said to be similar. This is the way. Let us go for the sums now. Next. One more sum. In the figure, ABC and AMP are two right triangles, right angled at B and EM respectively. Prove that triangle ABC is similar to triangle AMP. How have to prove? Look at this now. ABC is a triangle. Right. ABC and AMP are two right angled triangles at B and at M. Look at this. Prove that triangle ABC is similar to triangle AMP. Yes, how you prove now? AMP have to prove now. Okay. Next, second part of this sum I have to show that CA by PA is equals to BC by MP. You have to prove now. Same, these two triangles have to compare. Yes, they are even these two triangles only. In this figure, see, in the triangles ABC and AMP, which are the right angles here? In the triangle saying AMP, in the triangle AMP, angle M are right angles. You can highlight them. Angle ABC equals to angle AMP is equals to 90 degrees. Look at this now. Second letter comes here. This is from the data. Now observe very carefully. Angle BAC is equals to angle MAP, common angle. Angle BAC is equals to angle MAP. It is common angle for both the triangles. So by AA criterion, these two triangles are similar. Triangle ABC is similar to triangle AMP. When two triangles are similar, we have got first part here now, then their corresponding shades are said to be the proportion. That proportionality we have to go for that. How? AB by AM is equals to BC by MP. Look at this now. Yes, AB by AM is equals to BC by MP is equals to AC by AP or PA. Look at this now. We have to prove this. Take only these two from these three which they asked us to prove. We have proved. This is the way we have to go from that now. Okay. Next. In the figure, E is a point on side CB produced of an isosceles triangle ABC with AB is equals to AC. If AD is perpendicular to BC and EF is perpendicular to AC, prove that triangle ABD is similar to triangle ECF. Drawing the figure is important here now. ABC is an isosceles triangle, they only have given now. So AD is perpendicular to BC. This CB is produced to E and EF is perpendicular to AC. Yes. Now prove the triangle ABD. Which is triangle? This triangle ABD is equals to triangle ECF. ECF, how do you prove now? Look at this now. In the triangles AB, in the triangle ABC, you know that AB is equals to AC. It is an isosceles triangle. Therefore, their base angles are equal. So, angle ABC equals to angle ACB. Look at this now. These two angles are equal. Base angles of an isosceles triangle ABC. Now we have to compare these triangles. Now in the triangles ABD and ECF. Now which are the two triangles you have to prove? Those two triangles you have to choose. In the triangles ABD and ECF, which are the angles are equal, you know that? Angle D is equals to angle F. So, angle ADB is equals to angle EFC is equals to 90 degrees. They only have the data. And you know that angle in the triangle ABD, angle ABD is equals to angle ECF. We have proved just now. Angle ABD, look at this now. ABC or ABD both are same. Is equals to angle in the triangle ECF now. Which angle are going to take now? ECF. Correct now? Yes. ECF. We have proved. What is that we have proved? ACB. ACB or ACE angles are same, ECF are same. Therefore, by AA criterion, triangle ABD is similar to triangle ECF. This is the way we have to do the sums here now. Okay. Now, next one more sum. A vertical pole of length 6 meters casts a shadow of 4 meters long on the ground, and at the same time a tower casts a shadow of 28 meters long. Find the height of the tower. A vertical pole. You can take AB as a vertical pole. It casts a shadow of 4 meters long on the ground at a certain time. Yes. It is a vertical pole. It is forming a shadow of 4 meters on the ground now. A tower casts a shadow of 28 meters. At the same time, a tower is next to that. It is forming a shadow of how many meters long? 28 meters long at the same time. Then this is the way we have to frame the similar triangles. So how do you compare these two? At the same time, yes, that light inclines same angle with the ground at the same time here now. If the shadow formed by the vertical pole is 4 meters, when the shadow formed 4 meters, its height is 6 meters. When shadow 28 meters, we have to find out the length of the height of the tower. We have to find out. So here you can write now in the figure. AB is a vertical pole, PQ is a tower, BC and QC are the shadows are formed by them. What they are given here? AB is equals to 6 meters. Then BC is equals to 4 meters. QC or S is equals to 28 meters. Then height of the tower, we have to find out. In this case, that is PQ is equals to question mark. Two triangles are there. In the triangles, how do you compare? ABC and PQC. You know that it is a vertical cone, always it stands at perpendicular to the base. Angle ABC equals to angle PQC equals to 90 degrees. From the data, it is a tower vertical cone, naturally they are perpendicular to the ground now. Angle ACB is equals to angle PCQ, common angle. Because at the same time, this forms equal angle to the ground. It is common angle for both the triangles. Right. Therefore, by AA criterion, these two triangles are similar. Triangle ABC is similar to triangle PQC. When they are similar, corresponding sides are set to be in the proportion. Substitute AB by PQ is equals to BC by QC is equals to AC by PC. Let us substitute the known values here. AB 6 meters, PQ we do not know, question mark we have put. BC is the shadow formed by the vertical 4 meters and QC is the shadow formed by the tower 28. Therefore, do the cross multiplication. PQ is equals to 6 into 28 by 4. Because PQ goes to the numerator, 4 by 28 on the left hand side. Do the cross multiplication, 6 into 28 by 4. 4 ones are, 4 sevens are 28, 6 sevens are 42 meters. Therefore, height of the tower formed at the same time is 42 meters. This is the way we have to do the sums here now. This exercise. Next, one more sum is there. In the same way, you can do it. I'll read out, try to do, otherwise you can continue the next session. If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to PQR, prove that AB by PQ is equals to AD by PM. You know what is a median? Concept of the median you have to take and proceed so that we can get the sums here now, please. What is a median? Line segment joining the midpoint of the side's opposite vertex is a median. Draw that figure. Use the concept of similarity so that you can do the sums here now. Thank you. I will continue in the next session.